Hi, welcome to my channel. So we will extend from the past class. The last class that we have seen that equation of the wave in one dimension. So if we have a wave like this, we will take this one as at x equal to 0, and then we define a function that is f of t, which represents the y. After that, some time it travels some x distance, and then its shape becomes like this. We got the equation, similar equation, that is equal to t minus x by v, because it traveled with velocity v, as x t in t minus x by v. Today we will use one useful equation that is called sine wave. This is very important as per our subject. Okay, we will start with sine wave. Okay, so for sine wave, take one string and then move it in upward direction and downward direction, then automatically it makes a shape like this. So past class, okay, if you wave your hand in up and downward direction, then the spring will become like this. Due to the tension in that, it will vibrate, and then this energy will transfer to the particle and it will become a disturbance in the space. So at x equal to 0, at this position, we have seen the function that y is equal to just f of t. So if you see this one, this is looking like a, at this position, at any position, if you look at this position, then this particle after some time it will become a, it will goes up and it will comes down, it will goes up, it will comes down, like that it will make a sine function. So at t x equal to 0, at any time t, we can write that y is equal to a sine omega t, where a represents the amplitude of the function. Whatever we are writing here, that's a sine wave, it shows the amplitude. So this amplitude is nothing but the distance between the mean position to the extreme position. This is the mean position, because it's going up and it's coming down, it's going up and it's coming down. This will become mean position. These two are the extreme positions. So the distance between the gap between the extreme position to the mean position, we say normally amplitude. And this omega is equal to 2 pi into frequency of the wave. You know that frequency is nothing but number of cycles done in 1 second. For example, if it is moving like this, so it's going up and it's coming down, it's going up. So for full cycle is nothing but this one. So after traveling the 2 pi radians, so then 2 pi radians, we say that it completed a full cycle, and this is called one cycle. In 1 second, how many cycles it completed, that number gives that frequency. If you multiply with that frequency with the 2 pi radians, automatically you will get a omega, that is the angular frequency. So this is the time representation. At any time, what is the value of sine function? But anyway, our function depends on the both time and x. So we know that after distance x travel, if it travels some x distance with velocity v, we have to subtract this function with t has to be replaced with a t minus x by v to get the equation at that time. So we can write the function at x comma t can written as a into sine omega into, so this time has to subtracted by t minus x by v. So this is the periodic or sine wave. We say this one is a periodic wave, because it after some time again it will follow the same shape, so it's periodically it is forming its own shape. So we say that this one is omega t minus x by v. It shows that a sine wave along x direction and time. Okay, so you can change this equation into many forms. The popular form is a sine omega t multiplied by that, you will get omega by v into x, or else you can write sine omega t minus k into x. Okay, where this k is called wave number. So we will see why it is wave number. For any wave, if you consider this one is a time axis, then this will become a time period. Okay, so if you draw the same equation along x direction, y x direction, this will become a wavelength. So we know that it is taking some velocity. This is x axis, this is time axis. If you draw the graph along the between y and t, you will get a time period. If you are drawing that y value with respect to the x, you will get a x, that is lambda wavelength. So we know that velocity of the wave is v. That velocity can be written as, what we can write, that velocity can be written as length by time, so lambda by time t. So we can write that lambda into f. So v is equal to lambda into f. Okay, from this equation, v is equal to lambda into f, we can write omega is equal to 2 pi into f. So we can write f is equal to v by lambda, omega is equal to 2 pi into v by lambda. Okay, bring that v to this side, you will get a omega by v. Okay, that omega by v is equal to 2 pi by lambda, that can be written as k. So it is saying that in 2 pi radians, how much wavelength, that is nothing but that units are in 1 centimeter inverse for k. Because if you see the 2 pi per lambda, radians don't have any units, so we are concentrating on 1 lambda, it is in meters, so meter inverse or centimeter inverse, depending on CS system or MK system. Okay, anyway, it explains that how many wavelengths it is completing in the given interval of unit distance. That is importance of the k. K is called wave number. Indirectly says that how many number of wavelengths completed in given in unit distance, that is in per unit distance, how many wavelengths it's completed, that is given by the k wave number. So we can write that y is equal to a sine omega t minus kx, or else you can write omega by v is equal to 2 pi by lambda. You can keep 2 pi by lambda here and doing the LCM and bringing that omega is equal to 2 pi f. You can write like this, a sine omega can be written as 2 pi f into time minus k is equal to 2 pi. From this equation we'll keep this one as kx. Kx is equal to 2 pi by lambda. Bring the here 2 pi, here 2 pi is there, you can take the common as 2 pi. You will have ft minus x by lambda. Similarly, a sine 1 by t is nothing but a time period of the wave, you can get x by lambda. So this is also one of the popular equation to represent the sine wave. Okay, so this is the wave equation. So but if you see here, we are drawing two graphs, one is along x-axis and then other one is along y-axis, sorry, along time axis. See, this is x-axis and then we are drawing the graph like this, and then along time you are drawing the graph like this. So you should know that the path difference, and del phi, we use this one to represent this path difference. So to write these all those things, del phi, you should know the lambda value. For example, now every time we are starting from the 0 and then we are ending at some lambda in length. For example, if the wave is travel like this is called path difference, okay, or phase difference. That path difference can be calculated as the total angles, that is 2 pi. Anyway, we always compare with 2 pi because the wave is starting going up and coming down and it's coming completely. It's like indirectly it is like a simple harmonic motion in that it will complete the whole circle. So 2 pi by lambda multiplied by this gap I am writing as delta x. So delta x, if the graph is between y and x, we can calculate the phase difference as 2 pi by lambda multiplied by the delta x. That path difference. Okay, similarly, like for the time period, if the wave is started at some other time, then there will be some time difference will be present. From this we can calculate the phase difference is equal to 2 pi by the total time total time period multiplied by the delta t, whatever be the time difference is present. So from these two equations we can calculate the phase angle. After that you have to add to this one to make that function to be applicable, that is omega t minus kx plus some phase. Okay, that phase is can be calculated by these two equations depending on the equations. Okay, we will stick to the wave function, that is y is equal to a sin omega t minus kx. Okay, just wait, is technical problem. Hey. What happened to you? Okay, now each and every particle in the wave is going up and coming down. So what is the velocity of the particle? How do you calculate it? Anyway, the particle velocity always changes with respect to the time, so that's why we will say that particle velocity depends on time. So we will write that particle velocity as Vp, that can be written as change in y with respect to the time only. It is not due to the x. The reason is the particles are changing its position time to time, and the displacement is 0. Why it is 0? The reason is each and every particle will go displaced from its equilibrium position due to the application of the force. After that, due to the elasticity, again it will come back. So make sure that it is not changing with respect to the x, it is changing with respect to the time. So that is why Vp is dou y by dou t. Mathematically we will use this function that says that we are differentiating the y with respect to t only, keeping that x is constant. So that if we do that, derivative of sin omega t will become cos omega t minus k into x multiplied by the derivative of omega t is omega. So then it will get a into omega cos of omega t minus kx. Okay, it is saying that a omega cos of omega t minus kx. So here a omega represents the maximum velocity of the particle. Okay, when this will become 0, then it will become a omega as a particle velocity. So similarly, particle acceleration, we can calculate that ap is equal to double partial differentiation of the y function with respect to the time gives the acceleration of the particle. So for that, again you have to differentiate this function. It will become minus a omega, instead of this function that we are doing, because this omega a omega is there, and cos differentiation will be negative sin omega t minus kx. Again you have to do the differentiation of omega t, so you will get minus a omega square. So the maximum value of anyway here that sine function will be present, so that saying that acceleration will change time to time. So that ap can be written as maximum acceleration a omega square. Okay, this is about the particle velocity and particle acceleration. Remember that particle velocity changes with respect to the time only, not due to the x. That's why particle velocity depends on only amplitude and angular velocity, not on the physical dimensions of the rope or whatever string that you are considering. Similarly, ap is equal to a into omega square. Again, the particle acceleration also depends on only a and omega, not on the physical dimensions of the string. That is, we will see it. Next we are going to find velocity of wave. Okay, just give me a second. Okay, velocity of the wave. Just now we have seen that particle velocity. Now we will see the disturbance, how much fast it is moving. So velocity of wave I am representing with v point. Okay, so this velocity of the wave, that means the particles are is spreading from one location to other location. It is transferring the energy from here to here, and again it transferring from other point to other point. Again it is transferring energy from here to here. Like this, they are sending the energy from one point to other point. That means it depends on the particle motion. So we say that this velocity depends on the particle arrangement. So it indirectly says that we use two physical properties. One is inertia, and next point is we will write elasticity. Okay, from these two things we will explain that velocity of the wave. Okay, so first we will analyze the wave motion once again. If you take a string that we are moving up and coming down, then automatically it will goes up and it will comes down like this. So to understand the motion of these particles, not particle, the disturbance, we will concentrate on the peak point at this position. If you see the position, this disturbance is coming down. Okay, this disturbance is controlling and this is transferring to the other particle because of the tension present in the rope. So tension is in this position, in this direction, in this position, in this direction it is pulling down. So due to that it is coming down. So we will consider a small length of that rope. I am considering this one as delta L. Okay, so if you look at this thing, so as per the delta L I am taking the small value such that it represents a circle. So I am redrawing the same shape. This perimeter, I call this one as delta L, and it is a part of the circle having a some radius, or we don't know the radius. So I am taking that this radius as r, and this one is theta, this one also theta. As per the geometry, if you draw like this horizontal condition will be theta and theta. Okay, so from this body is coming down, this tension, this due to this tension, so we will use force F only because to avoid the confusion with time period. So this F provides a component in this direction, that is F cos theta. This F provides a component along this direction as F cos theta, that we have seen in the first class. So this is F cos theta, this F cos theta, both are same and then opposite each other, so both will cancel each other. And remaining terms, this force acting in this direction as F sin theta and this one is remaining F sin theta, both will create a resultant force. So I am writing F resultant is equal to 2F sin theta, and that too related to the center. So if you divide the force components at this position, they will act a force in this direction. This is 2F sin theta. This should be equal to centripetal force acting on the particle, because if you see this disturbance is transferring like this. So it's moving in a circular path, so this disturbance should possess a centripetal force that we can write as a m into v square by r, where m is the mass of this position. To calculate that one, we will consider a term called linear mass density. Why we are saying linear? Because we are considering only single string, so it will have only length. So mass density is nothing but something mass by one dimension, so mass by length. We will use the symbol called mu. So to calculate the mass of this length, so you have to multiply mu with this length, then you will get the mass of that one. So that mass can be written as mu times of the length of this one is, you can write as dl. Okay, this dl can be written as this angle is theta, this angle also theta, so we can write this one angle is total angle is 2 theta. So the arc length can be written as r times of d theta, but here we have a theta as 2 times, so 2 theta, not sorry not 2 theta, it's d theta. This one theta plus theta will become 2 theta, so this r multiplied with this whole angle gives the arc length, so dl is equal to r2 theta. So I can write mu times of r2 theta is mass. So I can substitute this value here and I can equate to this one. I will get the equation of the velocity. So I can write that mv square by r is equal to 2f sin theta. Just now I told you that we are considering the delta L is very small, so automatically theta will become small. So if theta becomes sin theta will be equal to theta, so 2f theta that is equal to mass we got this mu r 2 theta, so mu r 2 theta into v square by r will get cancelled, and then 2 will get cancelled, and theta got cancelled, and we have a v square is equal to f by mu, where f is the tension present in the string, remember. So v is equal to square root of f by mu. So this is the velocity of the wave on the string. You understand? So once again I will tell you the explanation of this one. See, the wave is like this, falling on the x-axis. So this disturbance is traveling from point to point. That means the disturbance is traveling only due to the particles displacement. The particle is displacing from here to here, and it transferring energy here, and then again it transferring. So the particles are coming back because of elasticity property. So the disturbance only moving in the x-axis direction. So to get the velocity of that one, we need to consider a small length on the string. So I consider the string here, and then I consider that dl length. I draw the same diagram. So at the topmost particle I am considering that it's having a two tensions along this direction. I divide into the two components, f cos theta got cancelled, and I have 2f sin theta. This is the resultant force acting in towards to the center of the circle what I have considered. So from this I wrote that that force acting on that particle should be centripetal force, such that the disturbance will travel in a circular path. So I should equate it to the mv square by r, but I don't know the mass value. To calculate the mass value, I am considering the new concept, that is mass density, linear mass density. That is nothing but mass per unit length. I want the mass of this one, so I have to multiply with the mu with the delta L. I will get mass of this small particle. So I calculate that mass, and then substitute in the formula, and then calculate the v value. So v is equal to root of f by mu. In earlier case we got vp is equal to a omega. This is particle velocity, and then acceleration also we got it, that is a into a omega square. Okay, here we got the velocity of the wave. Okay, there is no acceleration in the velocity of the wave, because we consider that wave is traveling with a uniform velocity v. That's why we wrote that equation f of t minus x by v, where this component is constant because of v is constant. Okay, so next class we will see the energy stored in the spring. Thank you.